A proof is a chain of logic. We start with what is given and reason step by step until the conclusion must be true.
So a proof is like solving a case, but you show every clue that proves the answer.
A counterexample is one example that proves a statement false. If someone claims a rule is always true,
one example that breaks the rule proves
the claim is wrong.
To organize our reasoning, we write a two-column proof. Statements on the left, reasons on the right.
Let's review. A proof is a logical argument used to show why a conjecture, indeed our suspicion, is true. A two-column proof starts with given statements on the left and the reason for that step on the right.
Equality properties is whatever you do to one side of an equation should also be done to the other side.
We use properties of equality from algebra and properties of congruence from geometry to show proofs.
Yes, Jaden, in algebra the symbol of equality is the equal sign, and the congruence symbol is used in geometry. In algebra, we justify steps with the properties of equality.
That keeps both sides equal.
In geometry, we often use definitions and congruence.
And those relationships help us build a proof.
Before we write proofs, we need rules. Mathematicians call them properties of equality and congruence. Let's start with the addition-subtraction property of equality. It can add or subtract any number to an equation as long as you do the same thing on both sides. The C keeps balance, Jaden. What is added to one side is reflected on the other.
Like an equation?
If two values are equal, add the same number to both sides. They remain equal. The same holds for subtraction. The balance is never broken.
It is like a scale. Add the same weight to both sides and it stays balanced. If A equals B, then A plus C equals B plus C. Adding the same amount to both sides keeps the balance.
Hooray, we're balanced!
The add-subtract property of equality states that you can add or subtract the same number from both sides of an equation. For example, if E plus C, then A minus C equals B minus C.
Here is an example. Given x minus 5 equals 12, we add 5 to both sides. Under reasons, the definition states the same number can be added to both sides. Balanced. We add 5 to both sides. What we do to one side, we do to the other. X equals 17.
All right, let's start with the given information.
The two angles are congruent.
Excellent, let's write that down.
And the reason given.
Now the reason?
Its definition of congruence.
Now a geometry example with angles. Angle A plus angle B equals 180 degrees. Angle B equals 50 degrees. Subtract angle B from both sides.
Elementary, my dear Laura.
Therefore, angle A equals 130 degrees, balanced between both sides of the equation.
Indeed, the addition-subtraction property of equality. Observe the proof, Jaden. Step 1. Given. Angle A plus angle B equals 180 degrees. And angle B equals 50 degrees. Step 2. Write the conditional statement and, under reasons column, the definition. Step 3. Substitute 50 for angle B. Step 4. Subtract 50 from both sides. That is the subtraction property of equality, which we write in the reasons column. Finally, angle A equals 130 degrees. Simplify.
The proof is complete.
Elementary, my dear Jane.
Written. Adjust balance and scales are the Lord's. Proverbs 16:11. Every equation must be kept in balance.
Adjust balance and scales belong to the Lord. All the weights of the bag are his concern. Proverbs 16:11.
Let us summarize. Add or subtract the same value from both sides. Equality is preserved.
Both algebraic and geometric proofs follow the same rule.
The game is afoot, Jaden. A new property awaits us, Jaden.
What is it, Mr. Holmes?
The multiplication property of equality.
Multiply both sides by the same number. The balance holds.
If two values are equal, multiply both sides by the same number. They remain equal. The scale does not tip.
Here's our example. X divided by 3 equals 5. Multiply both sides by 3. X equals 15. Step 1. Given. X divided by 3 equals 5. Step 2. Write the conditional if A equals B, then A times C equals B times C.
And under the reasons column, write the definition the same number can be multiplied to both sides of an equation.
Step 3. Multiply both sides by 3.
Write under reasons the multiplication property of equality.
Same number, both sides, every time. The proof is complete.
Now, division property of equality. Divide both sides by the same number. Equality is preserved. One condition. One condition. You cannot divide by 0.
Here's our example of the division property of equality. 2x equals 18. Divide on both sides by 2. X equals 9.
Step 1. Given. 2x equals 18. Step 2. Write the conditional statement. If A equals B, then A divided by C equals B divided by C. Step 2. Definition. You can divide both sides of an equation by the same number. Step 3. Divide both sides by 2. Under reasons, write division property of equality.
Step 4. X equals 9. Simplify. The proof is complete.
Well done, Jaden. Jaden, do you see what these two properties have in common? Notice something important about these two properties. Both keep the equation balanced.
They both do the same thing to both sides of the equation.
Exactly. Multiply or divide, the rule is the same. Do the same to both sides, and the balance remains.
The addition-subtraction property of equality works the same way. You do the same thing to both sides of the equation.
So whether we add, subtract, multiply, or divide, both sides must be treated the same.
Is written. Adjust balance and scales are the Lord's. Proverbs 16:11. In mathematics and in life, keep both sides equal.
Exactly. The rule is always the same. Do the same to both sides. Keep the balance. Keep the balance. Do the same to both sides. Keep the balance. Equality is all about balance.
Yes, like the scales. Equality is all about balance.
Equality is all about balance.
Yes, like the scales. Equality is all about balance.
Here, x equals y, as shown by the balanced scale.
So, 3 times x equals 3 times y.
We multiplied both sides by 3, and the scale is still balanced.
This scale shows that both sides are equal. Let's multiply both sides by the same number. The scale tilts, but it stays balanced. That's the multiplication property of equality.
We start with one duck on each side of the scale. To demonstrate equality, we multiply both sides by 4.
Now, four ducks.
The scale remains balanced.
Hello! Let's multiply these ducks by laying eggs. Yes, 1 egg each to keep the balance. Look, now there are 2 on each side. The scale is still balanced. Equality!
Can we do another one?
Sure, how about geometry?
Today is a simple but powerful idea, Jaden. What is it?
The reflexive property. Every number is equal to itself. Every segment to itself. Like looking in a mirror.
The reflexive property of equality. Any value is always equal to itself. Or congruence. Any segment at angle is congruent to itself. It never changes. It simply is. Reflexive property of equality. And congruence is like a mirror. Precisely. A perfect, identical reflection. Let us demonstrate. A handshake with oneself. A perfect congruence. Observe, I extend my hand, and my reflection does the congruence. A true reflection of equality.
The algebraic example is simple. 5 equals 5. X equals x. Any number is always equal to itself. It seems obvious, but in a proof, we must state it.
Therefore, start with the given. X equals x. X equals 5. Now write the statement. A equals A. Under reasons, write the definition. A number is equal to itself. Finally, write 5 equals 5. Under reasons, the reflexive property of equality.
A geometric example. Segment AB is congruent to segment AB.
That means the segment is congruent to itself. So it's always true for any segment. So it's a mirror image of itself.
Exactly. In geometry, we call that the reflexive property of congruence. Look at the proof. Step 1. Segment XY equals segment XY. That is given.
Step 2. Segment EX, y equals 5. Also given. Step 3. Segment AB is congruent to segment AB. A number is equal to itself. Step 4. The final step. The number is equal to itself. That is the reflexive property of congruence.
The proof is complete. The reflexive property. Any value is equal to itself. Any segment is congruent to itself. Simple, certain, unbreakable. Elementary, my dear Jaden.
Wow, the property of equality in deductive reasoning is powerful.
Indeed, let us discover more of its power. The symmetric property of equality says the order of equality can be reversed. In symbolic form, if A equals B, then B equals A.
So the order can flip, but the equality stays true.
In geometry, the symmetric property of congruence says, if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. These rules become the reasons we write in a 2-column proof.
Our rule today is the symmetric property of equality. If A equals B, then B equals A.
So if we know x equals 5, we can also say 5 equals x.
Yes, Jaden, first we write under the statement column, x equals 5. And under the reasons column, we write given.
So next we write a conditional statement. If A equals B, then B equals A. Under reasons, we write definition. The order of an equality can be reversed.
So now we apply the rule. If x equals 5, then we write 5 equals x in the statements column. And under reasons, we write symmetric property of equality.
Now we are ready to use these properties to build our first proof. A two-column proof shows each statement and the reason that justifies it. Yes, Jaden, first we write under the statement column, x equals 5. And under the reasons column, we write given.
So next, we write a conditional statement. If A equals B, then B equals A. Under reasons, we write definition. The order of an equality can be reversed.
So now we apply the rule. If x equals 5, then we write 5 equals x in the statements column. And under reasons, we write symmetric property of equality.
And each statement is written down. Each deductive step is written in logical order. Each hypothesis proven to be true.
The power of logic is explosive. It builds, ignites, and unleashes a burst of clarity, transforming ideas into profound revelations.
From ancient truths, a new power rises, transitive, defined, and exemplified. Unleashing heroes of equality, the battle for congruence begins.
The power of logic makes me energized. Just kidding.
A new property, Jaden, the transitive property.
What does that mean?
If two things equal the same thing, they equal each other, like links in a chain.
In detective work, I follow a chain. The suspect was seen here. In detective work, I follow a chain of clues. A print matches the suspect's shoe. The suspect's shoe was found at the scene. That is the transitive property of equality. This place matches that location. Therefore, the suspect was at that location. If the first is lit, and the first lights the second, then the second lights the third, the chain of light never lies. One clue links to the next. If A equals B, and B equals C, then A equals C. One clue links to the next. If A equals B, and B equals C, then A equals C. That is the transitive property of equality, a chain of clues.
So it is like a chain of clues. Each link connects to the next. Follow the chain and you reach the truth.
Here is our algebraic proof. Given A equals B. Given B equals 12.
And write the conditional statement, which our lanterns illustrated. Under the reasons column, write the definition. If two numbers are equal to the same number, those numbers are equal.
Apply the rule.
A equals 12 and under reasons.
Transitive property of equality. The chain is unbroken.
A is
B, B is C, A is C. The chain is unbroken. The chain is unbroken.
stronger than the sea. Through the waves was full and broken.
Our bond, the chain, forever unbroken.
Yeah, the chain is unbroken. Now a geometric proof with angles. Given, angle A equals angle B. Given, angle B equals 50 degrees.
And write the conditional statement, which our lanterns illustrated. Under the reasons column, write the definition. If two numbers are equal to the same number, those numbers are equal.
Apply the rule. Follow the chain. Angle A equals 50 degrees. Under the reasons column, the transitive property of congruence. The chain holds. The chain is unbroken.
A is
B, B is C, A is C. The chain is unbroken.
The transitive property. For equality, for congruence, follow the chain. Who links to the next? If A equals B and B equals C, then A equals C. In algebra, in geometry, in logic, in life, the chain of truth never breaks.
It is written, "Trust in the Lord with all your heart. In all your ways acknowledge him."
A chain of trust. The game is afoot. The substitution property of equality states that if two numbers are equal, you can replace one with the other. For example, if A equals B, then B can be substituted for A in any equation.
Today we study the substitution property.
What does substitution mean?
It means swap one equal value for another.
The witness said the coat was brown. The suspect owns one brown coat. I substitute coat with suspect. That is substitution.
That suspect looks like you. Anyway, if x equals 7, I swap up x for 7. Anywhere x appear, that is the substitution property of equality?
Let's write our proof. Given x equals 7. Given y equals x plus 3. We substitute 7 for x, y equals 7 plus 3.
The conditional statement. If A equals B, then B can replace A.
Under reasons, the definition. If two numbers are equal, you can swap one for the other.
7 plus 3 equals 10. Under reasons, the substitution property of equality. Now, we apply the rule.
Y equals 10. Simplify, proof complete.
Two values are equal, make the swap.
Replace but the other to stop.
X equals 7 takes its place. Substitute the value, solve the case. That is the substitution property. Elementary.
It is written, God sent his son in the likeness of sinful man, one substituted for another. Romans 8:3.
For what the law was powerless to do because it was weakened by the flesh, God did by sending his own son in the likeness of sinful flesh to be a sin offering. And so he condemned sin in the flesh.
Today we study the distributive property.
What does distribute mean?
Multiply what is outside the parentheses with everything inside.
Let us investigate a small mystery. Imagine 4 crates of supplies. Inside each crate are 2 telescopes and 3 compasses.
So each crate has 2 telescopes and 3 compasses. That makes 5 instruments in one crate. 4 crates would give 20 instruments.
Excellent reasoning. But we could count them another way. 4 crates times 2 telescopes and 4 crates times 3 compasses. Both paths lead to the same total. This is the distributive property of multiplication. Multiplication spreads across the numbers inside.
Let us write the proof. 3 times x plus 2 equals 18. Given. Write the distribution formula under statements and the definition under reasons.
The number outside multiplies each term inside. A times B plus A times C becomes AB plus A, C. Definition: multiply the number outside the parentheses with each term inside the parentheses.
Apply the rule. Distribute, multiply the 3. 3x plus 6 equals 18. Under reasons, write distribution property of multiplication.
This is the distributive property of multiplication.
This proof requires three properties. We distributed multiplication first. Now two more steps remain.
Next step, subtract 6 from both sides. 3x equals 12. Under reasons, that is the subtraction property of equality.
Next step, divide both sides by 3, x equals 4. Under reasons, division, property of equality. Proof complete.
It is written, "He with a generous eye will be blessed." Proverbs 22:9. Distribute what you have. Give to each what they need.
My children, remember, he who has a generous eye will be blessed, for he gives of his bread to the poor.
A generous eye.
Let us share this bread.
Thank you.
12:24 says, the word of the Lord grew and multiplied.
That's the distribution property in math.
Exactly. Distribute it and it multiplies. And the word. Let's share both.
We have mastered the properties of equality and congruence.
Each property is a rule we can trust.
Reflexive, symmetric, transitive, substitution, distributive.
And we proved each one step by step in two-column proof.
It is written, "Your word is a lamp to my feet and a light to my path."
Psalms 119:105.
The foundation is laid, Jaden. The game is afoot. The same proof can be written three different ways. We already know the two-column proof.
Yes. The other two are the flowchart proof and the paragraph proof.
Same steps, same logic, different format.
The evidence never changes, only how we present it. Two proofs, same steps, same conclusion. The two-column proof and the flowchart proof are identical.
The left side has rows and columns, while the right side has boxes and arrows.
The two-column proof lists each step in order. The flowchart shows how each step connects to the next step.
A flowchart proof shows the same logic as a two-column proof.
Each step becomes a box. Each connection becomes an arrow.
So it is like a map of the proof.
Precisely. Follow the arrows and you follow the logic. Observe the main branch here.
So each box is a decision point?
Precisely. It shows all the possible outcomes. This flowchart proof has two branches. Because it has two given statements,
The left branches. Box 1. Angle 1 is congruent to angle 2. That is given. One step, one arrow to the conclusion.
The right branch has two steps. Box 2. Measure of angle 2 equals measure of angle 3. Given. That leads to box 3. Angle 2 is congruent to angle 3 by the definition of congruence.
The conclusion. Box 4. Angle 1 is congruent to angle 3 by the transitive property of congruence. Proof complete.
Properties of equality, we know them all. Reflexive, symmetric, data standing tall. Add and subtract, multiply and divide. There's no proving from far. Flowchart proof, every reason shod. Chapter 6 geometry, we own law.